Hello, today I'm going to be talking about work, energy, and power, and more specifically looking at energy and conservative forces as well as the energy work theorem. So starting off with the relationship between work and energy, let's first define energy. So energy is the ability or capacity to do work, and essentially it's the ability or capacity to move an object, which can be transformed from one type to another. On the other hand, work is the process of moving an object itself. These two concepts come together in the work energy theorem, which states that the work done on a system by an external force changes the energy of the system. Next, I'm going to talk about kinetic energy and potential energy and relate them to conservation of forces. So, kinetic energy can be defined as the ability or capacity of a moving object to move another object. And kinetic energy is often modeled by the following formula. K is equal to 1/2 mv squared, where m is mass and v is velocity. Next, I'm going to talk about potential energy. Potential energy is the energy an object possesses in relation to its position or state of being. One common formula for potential energy is given by U, which represents potential energy, is equal to mg h, where m is mass, g is gravitational force, and h is height. So there are 4 different types of potential energy. These include gravitational potential energy, nuclear potential energy, electrical potential energy, as well as elastic potential energy. One more thing to note is... Alright, I think that's about all we need to cover before getting into the problem. That just lays out a base so that we can understand these concepts when applied to an example problem from an AP exam multiple choice section. So we're going to be looking at problem number 30 today. First I'm going to read the problem and then we're going to work through it together. So the problem states, how does the work required to accelerate a particle from 10 meters per second to 20 meters per second compared to that required to accelerate it from 20 meters per second to 30 meters per second? So we know from basic laws of energy that every moving object has kinetic energy. So again, we can refer to this formula right here. We can say that energy is directly proportional to the square of the velocity of the body, which is essentially what the formula says. So if we increase the speed of an object from 10 meters to 20 meters per second, then the total kinetic energy stored worked is equal to kinetic energy is equal to 1/2 mv squared minus 1/2 mv2 squared minus 1/2 mv1 squared. If we go ahead and plug in for v2, which is 20, and v1, which is 10, we'll get 1/2 times m times 20 squared minus 1/2 times m times 10 squared, which is equal to 150 m. So essentially you can just plug those values or do it mentally and you should be left with a result of 150 m. So on the other hand, if we increase the speed of an object from 20 to 30 meters per second, then the total kinetic energy will be equal to, let's say, K1 and K2. Will be equal to, again, using the same formula, I'm just going to go ahead and directly plug in 30 and 20 this time. Let's get 1/2 m times 30 squared minus 1/2 m times 20 squared, which if you plug into your calculator, you should get, or I mean, do it mentally, solve mentally, it's not that hard, 250 m. So according to the energy work theorem that I explained previously, energy is stored at work. So for the increase of speed from 20 to 30 meters per second, there is more work needed to compare the increase in comparison to the increase from 10 to 20 meters per second squared. As we can see here, 150 is very clearly smaller than 250. So we can say K1 is smaller than K2. Thus, we can answer the response and say that again, to restate the question, how does the work required to accelerate a particle from 10 meters per second to 20 meters per second compared to that required to accelerate it from 20 meters per second to 30 meters per second? So essentially what we just found is that the work, which is related to the kinetic energy, directly proportional to it, is going to be smaller from 10 to 20 meters per second than from 20 to 30 per second. So we can say that it is less. And this response corresponds to option A on the multiple choice exam. Thank you.